The objective of this lesson is to build models and draw representations of fraction division problems with remainders using the measurement interpretation. In previous lessons, students learned how to build and draw representations of fraction division word problems. This lesson will focus on interpreting situations with remaining units. Students will identify and explain the meaning of the remaining fractional parts of the model or drawing. Let's begin with the following division word problem. Charlene has 5 yards of colored ribbon. Each bow requires 3/4 of a yard. How many bows can Charlene make using all of the ribbon? This problem can be modeled using Cuisenaire rods. A purple rod represents 1 yard. There are 5 purple rods in the model because each purple rod represents 1 yard of ribbon that Charlene has, and she has a total of 5 yards. The white rods represent 1/4 of a yard. Since each bow requires 3/4 of a yard, the light green rod will represent the amount of ribbon needed for each bow. 3 of the white pieces are the same length as 1 light green rod. The mathematical question that relates to this model is how many pieces the size of 3/4 are in 5, or how many bows that each require 3/4 of a yard can be made from 5 yards. 6 of the light green rods fit alongside the 5 purple rods. We are then left with 2 extra white pieces that do not line up with a full light green rod. How do we describe these last 2 white pieces? Each white rod represents 1/4 of a yard in relation to the purple rods, so the 2 last white rods represent 2/4 of a yard. But that information doesn't really answer the question. We are concerned with how many bows can be made from the length of 5 yards of ribbon. Each white rod also represents 1/3 of a bow. Since each green rod represents the amount needed for a bow and only 2 of the 3 parts needed are available, the relationship between the purple and the last light green rod represents only 2/3 of the amount needed for the next bow. Although it may not make sense to make 2/3 of a bow, that is the meaning of the remaining pieces as it corresponds to the question. It also completes the answer to the division problem. If we have 5 yards of ribbon and divide it into 3/4 sections to make each bow, we can make 6 whole bows and we'll also have enough ribbon left to make 2/3 of a bow. Let's look at another fraction division word problem. While climbing, the tree squirrel can jump 3/8 of a yard in one jump. The tree at the park is 7 yards tall. How many jumps would it take him to climb to the top of the tree if he could go straight up? This time the problem will be modeled using graph paper. Drawn rectangles represent each yard. Since the fractional unit in the problem is eighths, each rectangle is drawn to include 8 sections. Each small unit square inside the rectangles represents 1/8 of a yard. The mathematical question being asked by this problem is how many 3/8 are in 7, or how many 3/8 of a yard jumps will the squirrel need to make to reach the top of the 7 yards tall tree. To answer this question, groups of 3/8 need to be made and counted. There are a total of 18 groups of 3/8 yards. There are 2 squares left that did not fit into a group. How do we describe these last 2 squares? Each square represents 1/8 of a yard, so the 2 squares represent 2/8 of a yard. But that doesn't really answer the question of how many jumps it will take to reach the top of the tree. Each square also represents 1/3 of a jump since it takes 3 squares to make a complete jump. So the 2 squares that are left represent 2/3 of a jump. So to complete the answer, if a tree is 7 yards tall and a squirrel can jump 3/8 of a yard in one jump, the squirrel will reach the top of the tree in 18 2/3 jumps. When solving fraction division problems with remaining pieces, recognize that even though the pieces have 2 possible labels, only one of those labels answers the question. Our objective in this lesson was to build models and draw representations of fraction division problems with remainders using the measurement interpretation. We met this objective by showing how to interpret the remaining pieces in relation to the question posed by the fraction division problem.